Power. And just change it there. Watch other. You said I could be flexible.
Block 9.
Do you remember?
Yeah.
Oh, sorry. You said I could change the things.
It's just the first topic. The way everybody look it into, right?
Okay, right.
So
okay. No, it's all right.
Securing the future.
Yeah, no. This is what the topic is.
Yeah. Securing the future, right?
Yes.
Nobody will look at it. First slide, they will look at it. Yeah.
Okay, there you go. Okay. First slide. I'll make sure the slides match the titles.
Yes. I'll do it. Safe copy. Right. Yeah. Okay, start it. Right. Stage is yours. Right. Yeah. Come on.
Yeah. Cool.
Right.
Okay, we good?
Right. Now, yes. You turn. Turn. Last.
Okay, you ready, Somanath?
Yeah,
ready?
You can start.
Okay, so thank you for coming today. So my name is Carsten Maple, as you know, those that were in the inauguration today. I'm going to give you a little bit of background first, but what we're going to talk about today is securing the future. That's what I'm going to talk about right now. And I'll be drawing on a whole bunch of research projects that we have, both at the Alan Turing Institute and the University of Warwick. Okay, so yeah, that's me. I lead something called the NCSC. Anyone know what NCSC stands for? No? The NCSC is our national cybersecurity center. Okay, so in the US there is an NSA, right? Heard of that before? The NSA. What do you have here in India? Do you have some kind of national body for cybersecurity? Somanath?
Yeah, we have security body, CIS2, security.
Okay, it's just a division thing. Okay, so the NCSC has designated in the UK 21 academic centres of excellence in cybersecurity research. So we are one of those academic centres of excellence. So we have a whole bunch of projects. It may be possible for those of you that are on PhDs to come and visit our lab. Harsh is in our lab part-time, but he's more at the Alan Turing Institute, which is the National Institute for Data Science and AI in the UK. And I mentioned this morning, some of you heard, there is a new national hub for edge artificial intelligence. And I'm the director for research innovation there. Okay, I'm going to start off. This whole course is called Trustworthy Digital Systems. Yeah, Trustworthy Systems, actually. And that's an interesting point because, sorry, can you plug that in for me? That's an interesting point because actually we talk a lot about trustworthy digital systems, and today it's more important to think about cyber-physical systems, okay? Because actually most systems have got some digital element, even though they're physical systems. So if we talk about the Internet of Things, for example, yeah, that has got a digital component, but very much a physical component made up of sensors and actuators. And I'll talk about that this week. But if we think about that word, trustworthy, what does it mean to you? What does trustworthy mean? Anyone tell me? I like to have an interaction with the audience because you will remember it more. Anyone want to offer up what they think trustworthy might mean? Or anyone want to offer up what they think trust might mean?
I think that can be trusted.
You think trustworthy is something that can be trusted, yeah? I think that's a good answer, okay? So what I want us to do first is to think about trust versus trustworthiness, right? So in my large project funded by the Gates Foundation, that $9 million project that I mentioned, the project was called Trustworthy Digital Infrastructure, okay? And in India right now, you are building a really advanced digital public infrastructure. That digital public infrastructure is what Aadhaar sits on top of, okay? So there is a vision in India for digital public goods, open goods, that sit on a public infrastructure. So part of that infrastructure is the internet, okay? Because we've got the internet already, but you need the building blocks upon it, okay? So what we need to do is make sure that it's trustworthy. Now, trustworthy, so here there's many definitions of trust. So, you know, one exam question we could set for you is to ask you about how many definitions are there of trust. Well, I can tell you, when I looked about 5 years ago, more than 300. One of the great researchers in AI, Jeanette Wing, who is Executive Vice President at Columbia University, has given a set of what we might call facets or elements of trustworthiness. But I want you, and this is important, to think about, and this was done by a collaborator of mine a couple of times, Kieran O'Hara down at Southampton in the UK, and he's got a paper, not archive, a general definition of trust. And this is a quote from him. So, trust is an attitude that one takes to the trustworthiness of another. In turn, trustworthiness is a property that they have, okay? So what I want you to do is be really careful about this, because I'm going to explore now trust versus trustworthiness, okay? So, trust is, so it's something that you have. So just like you said, something that's trusted. So, Somanath, you might trust me, yeah, to borrow your phone, yeah? So Somanath trusts me, okay? So it is a relationship. So we can even formally mathematically define this, which I won't do, but we can say A trusts B, given some kind of conditions, yeah? Now then, if Somanath is going to trust me with his phone, what do you think Somanath might have made that decision based upon? What do you think? So there's no wrong answers, okay? We've had one answer so far and it was right. So what do we think trust might be based upon?
Historical data.
Sorry?
Historical data.
Historical data. Good. Tell me what you mean by historical data, though. What do you mean?
He has been assigned some kind of task earlier and he has completed those tasks.
Very good. So what happens is, so don't forget this is about Somanath trusting me, yeah? So I have delivered previously, right? So the historical thing, and you'll see why I'm getting this nuance in a minute, that I did something in an interaction with Somanath, and he has got a history of that, which he satisfies. So he says, I'll trust Carsten, okay? What else might vary?
The person's accountability.
Oh, very good. It could be accountability. So what you could say there yeah, is if I say, I will give you this, if something goes wrong, then I will do something. I will be responsible or accountable. Very good. Any others?
Proper legal documentation.
Okay, so some, let's put it as legal recourse, okay? And this is one thing that's important. Has anyone heard of data trusts? Yeah? A data trust is actually a mechanism for sharing data, yeah? So you might have a sort of data lake, everybody puts some data in, yeah? And what you do is you then create this thing, this legal framework that says, if you do something wrong, then I will sue you. So lawyers get involved in this. Lawyers love data trust because it's very expensive for a lawyer. But I will talk to you about technical mechanisms for sharing data, yeah? So where we can get a shared intelligence. So over this week, I'll talk to you about that. But this legal recourse is a very valid one and is used for big organizations typically. And it has to be a big organization because you've got to be able to sue them. There's no point saying, you know, there's no point if I say, can I borrow this off Somanath? And Somanath, I say, and if I break it, I'll give you £1 million. Because I don't have £1 million, okay? And if I did, I wouldn't give it to somebody. You try really hard to get it, but no chance. So it needs to be appropriate. But I hope I've given you another clue about something that's important there. I'll do one because you've done 3 already. But one is the value. Yeah? And it's the value at risk. Yeah? So the value at risk in this is quite obvious, right? Because it's a phone and a SIM card and it's worth a bit. And there's no data on it or anything like that, yeah? But that, so we can say, what, 1,000 rupees or something? I don't know. Oh, no, 10,000 rupees, sorry. I meant 10,000, my conversion was roughly, yeah? And then you can make a decision. Yeah, so we have to think, what if it goes wrong? If, on the other hand, it was some data on here, then that's a different question, right? Because it might have something that's really important to Somanath on here, and it's his only version. If he loses that, could be some real problems, right? So we have to think about value at risk as well. And there's a whole bunch of others. But one thing I do want you to think of is that it is definitely based upon time, and really time and necessity. And this is really important when you're making systems, yeah? Now then, you will all have done this, yeah? But you will have made a decision about something which was different because of the timing, okay? So I'll give you one example. I don't think you have GDPR in India, do you? You have GDPR? Okay, GDPR, right? With GDPR, it says you need active consent, right? So it means if someone's going to use my data, I have to agree to it all. So I'm going to give you an example where I, because of necessity, which I've not spelled right, which I actually end up trusting more than I should. I don't really trust, but I accept. And that's one of the things that's important about when we accept rather than just when we trust, okay? So the way that I do it is when I go to a website, it says, sometimes it will just say reject all. Like, great, I'll just do that. I don't want to give you anything, yeah? Other times, you have to opt out of every single one, yeah? So first of all, the fact that we've made it that I have to opt out of every one, I don't like it. I think you're being deliberately causing some hard work. But when I need to find some information quickly, yeah, so there's a need and it's pressing, yeah, then I'll act differently, yeah. Now what I will typically do, so long as if there's a need, if I've got a bit of time, what I will do is I will find another source for that information. Yeah? When I can't do that, sometimes if I have a quick look, can't find anything, I will accept and go, there might be some bad consequences. Yeah? So I want you to think about that. And it's important when we design systems. So one example is, and this also happens a lot, if you design a system and let's say it's access to the internet, you've got a Wi-Fi point, and there's no cellular signal, yeah? Then if somebody really needs to send off a job application, yeah, a lot of value at risk, yeah? So it's really important, it's really necessary, they're gonna lower what they do, right? And this is a term that's been called meaningful consent, because that kind of situation where you gain the trust or the consent of somebody, if you are doing it when it's a desperate kind of thing, it's not really meaningful. They don't really mean to consent, right? So that's a little bit about trust, yeah? So I want you to think, if you're ever designing systems, think about that, the trust element, yeah? Think about the position of the person that you're in. On the other hand, trustworthiness, yeah, is something that we haven't put down here. So there's two real things. I should put another thing down, actually. One that we haven't put is reputation. Yeah? We didn't put that, and that reputation and recommendation. I think we've all done that before, right? If somebody's known to be good. And that's why I wanted, when you first said historical data, I asked a little, because the historical data that's most important is with ourselves, right? So the historical data, most importantly, if you design a system, will be the experience of the users. Yeah? But other times they'll say, no, your reputation, you've got really strong engineers, you've done things really well before, somebody says they're very happy, etc. But one thing we haven't put on here is, and I'm going to use one word to incorporate a bunch of things. Sorry, can you see that? Are you okay seeing it? Can you see all the writing? Yeah. Cool. One thing I want to put is certification / accreditation or something like that. So if something, you know, if you've got a vehicular system and it's got 21434, which is a cybersecurity standard for vehicular systems, yeah, then you say, oh, trust that a bit more, yeah. If it's got an ISO, you know, those standard, you trust it a bit more, right? Because somebody has done a conformity assessment against that. So again, another thing, you want to build a trusted system. These are things that you've got to take into consideration. They're things that you might be able to, you know, at least consider time and necessity, but the others you can actually do something about. You can seek certification. Yeah. So these are things on which trust is based, and the reason that I say that is this certification accreditation is something about a quality of the product or process, right? Yeah. And that's where trustworthiness comes in. So other people have got other definitions. I've got my own definition, but I decided to use this one because it was nice in just one sentence to say the two, and it fit on a slide. So this was from a research talk I gave recently. So trustworthiness is a property that they have. So what trustworthiness is that? This is starting to become more common now. We use something which is trustworthiness. Yeah. Is based on a set of claims with associated evidence. Yeah. So this will be important. I'm going to talk about trustworthy systems in a moment and ask you what trustworthiness is, what kind of bits of trustworthiness there might be. But what you can do is, the trustworthiness is something about the system. Yeah, this phone, you know, trustworthiness, you know, I might trust it a bit more if I know it's waterproof to 5 meters or something like that. Someone's done some testing, right? So trustworthiness is about something about, it's a property, as Kieran calls it, but I call it, it is a property, it's something that's intrinsic about it. But what I say is, it is a claim that has got some evidence. Now, this is really important because AI, there's a lot of work on trustworthy AI at the moment, yeah? And that's really important, and it's hard, right, to get the right claims and the right evidence. So when I, in 2019, I went to a conference called ID for Africa, yeah? And when I went to a conference for ID for Africa, there were lots of vendors there that were selling ID systems, yeah? In fact, there is one that wasn't really around then, but is now, something called Modular Open Source Identity Platform. Anyone heard of that? So MOSIP is actually written by the lead architects of ADHA, but funded by Gates. They're creating an open version of it, right? An open source version. But back at that time, 2019, there was much less. Identity systems were being developed. And somebody said, in fact, so many people said, we use privacy by design. Yeah? Now, privacy by design is really easy to say, but really difficult to do. So this might be a claim, yeah? A claim that people are making. These are big companies, you know, Gemalto, now Thales, you know, IDEMIA, saying we are very private with your data because we do privacy by design. So I asked a couple of companies, about 3 or 4, oh, it's really good that you do privacy by design. Tell me about how you do privacy by design. And their answer was, we use 256-bit encryption. Now then, look at that statement. You are privacy preserving, you use 256-bit encryption. Anybody got any comments about that claim and the evidence? Now, of course, they were just trying to convince me, right? They weren't giving me something formal, but still, what is wrong with their claim and evidence?
Claim can be considered as a not genuine, but it has always been considered genuine.
Genuine, you said? Not quite. Tell me what 256-bit encryption means. It means you encrypt the data, right? It's 256 bits. Is that equally? So first of all, there's 2 things wrong with this claim, I'll tell you. One is, it's not a privacy evidence, it's a security evidence. Privacy is not about protecting data in transit or in storage. It's about what people can learn from and what people can do with your data. Typically, encryption, yeah, is used. Encryption is used to prevent unauthorized access, whereas privacy is a problem with authorized access, right? So that's why we have GDPR. That's where privacy by design principles came from Anne Kevorkian. Yeah. So the thing is, you know, they were giving the wrong term. Actually, if I really thought they were smart, I could have thought that they were using homomorphic encryption. That would be 256, but it would mean something, okay? But they weren't, yeah, because people weren't doing homomorphic encryption at 256 bits right then. Okay, so the first thing is, it's security, yeah? The second thing is, how secure is 256-bit encryption? Can you tell me how secure it is? The answer is no, because you need to know which algorithm I'm doing. Can't give it. So what you've got is a claim that was in the wrong area and partial information, a partial claim, right? Because you have to tell it. Because if you use, you've been taught crypto already, yeah? Just you, yeah. So you've done elliptic curve cryptography. Elliptic curve cryptography is stronger in many ways, so you don't need the key size quite as big. So that's why you have to tell me enough information, okay? But I want you to think trustworthiness is based on a set of claims with associated evidence. And there's a couple of things about this that are important. One is, I want you to remember this term, please. Justified trust. You're going to hear more about this in the future. But if you have a set of claims and evidence, it enables not trust, because too many people trust things that they shouldn't trust. I'm afraid we're human. That's why there's lots of scams around and they're still growing, because we trust things we shouldn't trust. Yeah. Other things are, trust is very personal. Yeah. So the thing is, I could give a set of claims. I could tell you something. I've got some reputation, some history, or whatever. Somanath might trust me, and somebody else in the audience not trust. That's fine, because it's a personal thing, right? But if you have this, you can have it's almost now sort of auditable. You release a version of something, and you say, here's the test that I've done for this version. Based upon all this information, you trust or not, but when you trust it, you've justified it to yourself. Okay? So this is an important emerging property that we're going to see more of in the future. In fact, I'll give you a bit of an example, but it's not quite as formal for trust. But has anyone heard of a model card? Anyone heard of model cards? No? Okay, so if you want to see a model card, go to Google Gemini, for example, Gemini 2, and it's got a model card, and it will tell you about the development, what it's going to do, what its inputs are, what its outputs are, yeah? And sometimes Gemini 2 is not very good for this particularly, but others are good examples where they tell you the data that was used. Yeah, now that can be important because that data for a machine learning model, you want to make sure the data is representative, right? That's why what we do at the moment to say, look, this is really good and trust the output, trust the work, is to say it's got billions of parameters, right? Because we associate bigger is better at the moment, yeah? But it's one element that we're seeing a lot more. So I think it was 2018 Google started doing model cards for AI, but they are becoming pervasive now. Okay, so any questions or comments? You're all experts on this now, yeah? Okay. Next thing is, does anyone know how you might determine the trust in a model, in a system? Anyone got any ideas at all how you might do that? How do you find out if a user or a set of users trusts your system?
We have a different parameter to see the function. So through that functions, we can measure that the system is working.
So you can get okay, you could use a proxy, right? So if people are going through and completing something, you might say implicitly that trust them. Some of the big areas now are these. So these are things that one's got to consider yeah, when trying to find out if somebody trusts the system, okay? So there is user acceptance testing, yeah? So finding out, does the user accept what's going on? I'm just doing a piece of work on a model that is not trustworthy at all. And the reason it's not trustworthy is it's not explainable. So there's a model, yeah? And what it does is you put some inputs in, and it gives you this, it's a black box, it gives you some output. They sort of describe the black box in the middle. But if you are building a system, sometimes you need to satisfy a regulator. So this is a finance system, okay? And this finance system is a very, very important piece of the regulatory landscape, because what it is, it's about investments, yeah? Do you take or allow people to invest in some kind of fund that you've got? Now, there are many people that are forbidden, they're sanctioned from investing because they've been known to, their money has come from certain sources that are nefarious, okay? So it's really important that when you screen, it's called client screening, that you check against people. But sometimes, you know, you might have Somanath, yeah? And sometimes it might say Professor Somanath Tripathy, it might say, sometimes it may say Som. How do you do this, what's called fuzzy name matching? I'll come back to that again later this week. This fuzzy name matching is very important. So what happened was with the system, they were altering parameters under their user acceptance testing and trying to determine were they getting the right number of false positives and false negatives, right? So in finance, a false positive is bad because if you get too many false positives, it means that you've said somebody should not be able to invest. Yeah? Now, the first thing you've got to do is you've got to check that. Yeah? A false negative, on the other hand, is that you're going to take some money off somebody, right? So you've got two cases. One, it costs you a lot of money, the false acceptance, because you've got to go through all the false acceptance. Yeah? Because you've got to go through, because it said you shouldn't be taking money off them. So you need to check about all those. And the other is, as I said, false rejection, where you are going to take the money off people, right? And that, if you don't get, if that side, that's where the regulator gets annoyed, right? Because you're taking money off people that you shouldn't have done. So they'll accept some errors, but not many. So this system, this was user acceptance testing, yeah? And actually the user acceptance testing failed. They did not understand the system. They did not trust the system. I've looked at it. I've done a lot of work. And it is really difficult. It's really complex, the name matching system. You cannot see how changing one letter definitely will give you a different score at the end. Yeah. And if you cannot explain that, it can be difficult. Others are technology acceptance models. That's typically from health, yeah, where you want to build in some new technology and you're working with the person who's going to have the new technology to make sure it works, typically on a one-to-one basis. You've got others, which include world cafes. World cafes are actually something that's very, so do I want to say informal? It's very qualitative. It's not quantitative, but a world cafe is where you meet users, right, of a system, and you elicit ideas. It's not the most formal. It's not formal like something like a nominal group or focus group, yeah. But it is an area. I won't go into human computer trust models because I haven't got time. But discrete choice experiments, yeah, are another way to get understanding of users when your system is very complex. So I'm not going to go through these slides now, the next slides, because I'll go through these discrete choice experiments next week, later this week. But I am going to talk about trustworthiness. In fact, yeah, I'm going to go through this trustworthiness. So some of you may have seen that. What do you think trustworthiness might be? And I can tell you that I've told you 3 things already. Yeah. So one is security. Yeah. If it's secure, we might trust it. Yeah. One is privacy. One is explainability. Anything else that would make a system that you could make some claims about, that someone would say, yes, that's a claim. And I should say, first of all, when I put those the things like the user accepted testing, yeah, we have to think, yeah, that it's where we can, we should give the right evidence to people. Yeah. So don't give them the wrong evidence. So one way to work out what kind of claims do you want me to make is by having those kind of determining trust mechanisms. Yeah. So ask the people first what they think is important, and then you can say, right, I'll give you some claims and some supporting evidence. So, but these are things that people might want to see. Security in the system, privacy, explainability, anything else? Any suggestions that might make you trust the system? You got one? Any suggestion? No? Anybody? Well, I will tell you. I'll tell you something. So things that you might do, and it was over there as well, is you might say accountability, right? If it's accountable, if somebody's accountable, then that might help you decide, yeah? Other things would be fairness. You might not, you don't want to be discriminated against, right? So that's going to be important, yeah? So if you're going to use the system, you think, well, is it going to be fair to me? You could even say, you know, it's not really one of these, but you can look at the sort of performance, yeah? And one thing we might have is reliability. Does it act the same way each time? Is it reliable? Does it do the right thing each time given a set of inputs? Yeah? And there's another word that's closely related to this. Robustness. Now, these 2 terms are used interchangeably, but I'm going to tell you what I mean for each of these. So reliability is that it is consistent, yeah? For a set of inputs, it will give you always the same output. That's not always true on systems, especially large language models, right? It can be, they can give different, they certainly give difference if you're different users, so you might say there's fairness issues, yeah? But reliability, but robustness is, what if I give it slightly different data? Does it behave how I expected it to behave? And again, a good example with LLMs is we've got some problems where we put these guardrails, and if, even though the system's got guardrails, if you just do the right perturbations, yeah, it doesn't act as it should do, right? So it's new data, so it's not that it's reliable and repeatable and consistent, but if you give it data that it wasn't expecting, it should still work a bit, right? And this is, you know, in AI systems, this happens, you know, the robustness is, what if there's, for example, what happens if the data drifts? Yeah, the data that was used for training has got some statistical properties or other kinds of property. A robust system would still work well if the data had different distributions or looked differently, right? So that's what I'm talking about with robustness, yeah? And then finally, and we'll talk about this, I think it's this afternoon, it's security, not privacy and security this afternoon.
No.
Oh, it's privacy and security we're talking about this afternoon. Might swap that around. We're going to say, yeah, okay. But resilience is where a system is resilient to attack. Yeah. So if there's an attacker in the loop, a resilient system, resilience means to withstand, right? So a resilient system would be able to withstand. Yeah. And there's a whole lot of work that you'll learn about, which is security is not enough anymore. We need to work on resilience, but I'll talk about this afternoon. Okay, so let's look at what these trustworthiness facets, as I call them, are. Okay, so there's these, and there's many more as well. Okay, so if you want to look, you can either look at my paper on trustworthy digital identity, yeah, or you can look at Jeanette Wing, who is one of the world's leading computer scientists and AI people. And she did something on trusting communications of the ACM. I think it was in communications. There's two big, highly cited things, communications of the ACM and ACM computer surveys. I think it was communications of the ACM, okay? So, but when I did this in 2019, I said, so I looked at the research, I looked at the many definitions of trust, and I thought which ones were important that one could get some kind of measure for, and I came up with 6 categories, yeah? And I worked with a couple of profs at the Turing on it as well. But what we were looking at is security, privacy, ethics, reliability, robustness, and resilience. So I've told you about these a little. But here you can see the terms for reliability, yeah, protection, yeah, so that it can withstand something. But also a resilient system should be able to detect that it's under duress, okay? So there should be a detection element, and there should be a recovery part. Can it keep operating? It's something that's resilient, should be able to still work, even though it's under some duress, should still be able to work to some minimum level. Yeah, so minimal operating level. So that's resilience there. And we split security into the standard CIA, you all know that, confidentiality, integrity, and availability. And we did think about it for a while, and we just thought, you just got to go with the basics there because it's really well understood. But ethics, some of the key elements that we put in, so we're going to think a bit more about accountability to others, but is it transparent? Is it explainable? And is it fair? Let me just work through those things. Fairness, you all understand, yeah? So I told you just then what it means, and we've got different tests for fairness. But transparent and explainable, especially if it's in your second language, might seem a bit, well, aren't they the same? But I just want to tell you a little nuance about the two. Transparent shows you the operations that you might have done. So think of it like a black box, yeah? But instead of it being black, we make it white box. So you can see, this did this, that did that. So you know how decisions are made, yeah? Yeah? Explainable is the why. Why were they made? Why did you? I can see what you did, so thank you. But why did you do that? Yeah? And that's what I said, that it was the important thing about why is changing one thing, why does it lead to something else? In fact, that system was not explainable or transparent that I mentioned, that finance system. But that's how you can separate these out. Many people conflate the two, that's fine. We just needed a system to do it. And for privacy, we had privacy in communication and privacy in processing. Okay? So I'll talk about privacy enhancing technologies this week as well. So I want you to go through trust and trustworthiness. Now I'm going to go through, and I think we'll talk about them a bit further after the break, so I'll finish a bit more. But emerging and future developments impacting security. Okay, so now I'm going to talk about some of the future of security. But what was really important is that we understood what meant by trust and trustworthiness, because otherwise it doesn't set up the whole course. So, tell me, can anyone think? We're going to try once more a little bit of brainstorming. What is current or emerging that's impacting on security? Anything at all? It's a term I've mentioned quite a few times today. Can't hear because of the door. Did you say anything? No? Yeah. What's the number one thing that's really changing loads in the world that we live in right now? Sorry? What are you going to say? So discrete technology. And? Language, what? AI. Yeah. Number one, right, is AI. There's all sorts of things. There's loads. We'll go through some. AI is the number one thing, right? Anything else that's coming up, that's emerging? Cloud computing. Okay, so that's good. In fact, I would say cloud is here. Really. I'll talk about that in a second. Let me just finish this on cloud, because I think it's a really good point, because we are getting far much more that think we're having cloud native, right? But one thing is, I think that largely we're close to the top of the curve on cloud, right? Because we've done that. Actually, if you look at security, and there's something I'm going to talk about in a minute, but I'll give you an idea about it now. But if we talk about security, you know, cloud, we've managed to get so much into the cloud now that we're now talking about maybe having things a bit more localized, right? And people have public and private cloud, right? So if you count cloud as public and private, but cloud used to be that public cloud really, private cloud, and people having on-prem sort of cloud, right? So people are coming back to having on-premise computing with the ability to have some elastic additionally, but they're starting to have some more. But I think what's more important is the cloud is important, because cloud, I would say, and really what we might call 3-tier. So I typically think of it as 3, some people think it's 2, or edge. So I mentioned this edge artificial intelligence center, yeah? And I think this is going to be something that's much more, because it fits in with something that I mentioned before, the Internet of Things, right? So you all know we've got IPv6, yeah? What was one of the main drivers for IPv6? Security, yeah, that was a big one. But also the space wasn't big enough on IP4, right? You couldn't have all of the devices that we're going to have. How many machine-to-machine communications directly we got now? How many machines? I mentioned this morning, you know, people having multiple mobile phones. There's 2 laptops in there. I actually work for the United Nations. I work for the Financial Conduct Authority, a regulator in the UK, and HSBC, and they all want to give me different credentials and different laptops, yeah, these all need that addresses, yeah. Also, yeah, we also have, when we've got lots and lots of sensors, you think about it for detecting rain or weather sensing, yeah, air quality sensing, many sensors that we've got that need, we need to be trust where the source came from. So I think what we'll see is much more of, yes, some cloud, but definitely 3-tier and edge, because the edge means you can process near to the center. And it's interesting because it was a good thing to say the cloud, because the cloud, we think of, does everyone think about this cloud as this central thing, yeah? Yeah? It's not really, you know that, right? You know it's massively distributed, right? Has anyone heard of the company Akamai? No? So Akamai are a company that have got very good technology. And what it does is, if you've got YouTube videos, yeah, they're in the cloud. All agree with that? Apart from they're not really, because if they're in some data center in Iceland or in Seattle or in Bangalore, yeah, that's a lot to collect up. So what it is distributed, and what you do is, what Akamai does is say, where do people really view this stuff? Because a lot of things that we view are localized, even things that go viral, yeah? So this kind of edge is what we're having with big data centers already, but pushed down to the edge, which is, for me, this is why I said 3-tier, because you've got the cloud, yeah? Then you've got some localized sensing, some localized aggregation. So it can be big, like CDN, content delivery networks like Akamai, but typically it'll be smaller, yeah? So you might have some Kubernetes thing here or some small sensor. A good example would be on some of the more intelligent traffic systems where you've got roadside infrastructure. So a number of different sensors and traffic lights and things, and you connect them to a local thing, and then you get these to speak to each other, yeah? So you've got something at the edge, and of course a car is one of those things that speaks to the infrastructure, right? So that's properly the edge. You have this sort of 3-tier kind of process. And the reason I call it 3-tier is because we did have a large project working with Jaguar Land Rover, as you know, JLR, TCS, not TCS, sorry, Tata. Not Tata Motors, not Tata Consultancy Services. But yeah, so there's 3 things. Okay, let me just have a look. Okay, let's stop there because it's 4 o'clock, yeah? And what we'll do is we're going to dive in a little bit more. So I'll just move some slides around and we'll dive in a little bit more for the second hour. So we've got 15 minutes break. But before that, are there any questions that you might have? I can't hear you, sir. Nothing? Okay.
I have a question.
Okay.
So can you provide an example? How can you become a model externally?
Oh, very good. Right. Right. So there are lots of ways that you can do explainability. Okay. I'm going to give you just a couple. So one of them I'll get you to look at yourself is locally interpretable model explanations Now, the basics of that, of LIME, as it's called, what you do is, because you've got a big model that's doing lots of things, and don't think so much necessarily about an LLM, because they've got almost infinite, they've got a massive space of information that can go into the model, and a massive space of things that can come out. But think about something where actually it's a little bit smaller, a bit more constrained, yeah? So you've got some, but still large input space. You've got a black box and you've got some output space. what you do is you have an interpretable model. You compare that model to something that is locally interpretable. So you make it a lot smaller, and a locally interpretable model explanation gives you ways to get an idea of how the model is working, or compared to something else, at least in a small setting. That's one. Another is, and we're doing some work on this right now, counterfactual examples. Yeah, counterfactual examples are examples where if I've got a model, yeah, in fact, I'll give you another one as well. Shapley values, yeah. I'll start with Shapley values first. Shapley values, what they essentially do is either with a single, called a local Shapley value, or a global Shapley value, what it does is it says of a whole set of features, yeah, that feed into your model, which ones are the most important. So a different version of this, but not quite the same, but it gives you an idea, is a principal component analysis, that's PCA. So Shapley values are global or local. James can give you that. Counterfactuals are slightly different in a sense, but what the counterfactual does, and it's very, very interesting, I think, is it says, if I've got a decision boundary and I run with a certain set parameter value set, and I get a decision, what is the smallest change I can make where the decision changes? So for example, if you were going to get car insurance, yeah, and it was, you know, a level here, how much can we change just a little, maybe, you know, your salary or something like that, so that it becomes a lower price? Same with life expectancy. You might have a model that says we're going to work out how long people live, and we're going to ask people, you know, what time do they go to bed? How much do they eat per day? How much do they exercise? Yes, you've got all these different parameters. And you say, right, your life expectancy is 79. You say, well, what would I have to do differently to get 82? Yeah? It says, oh, just go to bed 1 hour earlier, and that would do it. Yeah? So that gives you an explanation about, because what you know is how much this thing mattered. If you'd have just had this bit different, you'd have had a different result. And the PCA and Shapley values are doing exactly as well. How much did each factor go into being important for this? So what you have to do is you have to run lots of tests on it, right? So that you can get an idea of the space and say, well, which was important for that space? Okay? Any other questions? Good question. Okay. Well, let's take 15 minutes. That's all right, and come back at 20 past. So feel free to go and stretch your legs or.